So 8.1b, we're still dealing with radicals here, will be for the rest of the chapter, and we are on example 2. And so let's just, I would write these down in the notes. You are going to need them on a test as far as knowing how these all work. So we've got the cubed root of negative 8. This is odd, and this is a negative number, so that means it's doable. What number times itself gives me 8? 2 times 2 times 2 gives me 8, but I need a negative 8. So if I put a negative there, these two give me a positive 4 times this negative 2 gives me negative 8. Okay? So negative 2 is the answer for that. All right, the B part of this equation, or these examples, it says cubed root of negative 64. What number times itself 3 times gives you negative 64? Well, 4 times 4 is 16 times 4 is 64. That is a cube. We're wanting a negative, so I have no options except to make all of them negative and see if that's a true statement. So what I do, I look at the number here, and I look at my index and say, okay, I need to multiply a number by itself 3 times to get this number. So I just instantly put down 4 times 4 times 4. If this is a negative, then I make all of these negative, and then I know I'm okay. So if this is an odd number, you know it's doable. If this were an even number, you'd write, can't be done. But if it's an odd number, then you can do a negative radical. So look at those two first. Odd number, negative, okay, at least it's doable. Radical, or the root of this, the cubed root of this, what number times itself 3 times gives me 64? 4 times 4 times 4, that's negative, 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 negative. I be done. Negative 4 is my answer. All right, B, or that is B. C, square root of negative 4. Okay, what do I look for? Is this number even or odd? Well, if there's nothing there, it's an assumed 2, so it's even, and we've got a negative, can't do it. Okay, so I'm done. Negative square root of 4. The negative is outside the radical sign, so I don't worry about it until the very end, and I tag it on. What's the square root of 4? 2. Bring my negative over here, and I'm done. E, fourth root of square root of, or fourth root of negative 16. This is an even number, that's negative, can't be done. Okay. F, negative fourth root of 16. This negative here, because it's outside of the radical, has nothing to do with the radical, so we just leave it alone until the end. What number times itself gives me 16? 2 times 2 times 2 times 2. What number times itself 4 times? This negative gets tagged on there, and I'm done. Okay, so those are the basic 6 different things you're going to run into on these. So let's keep practicing these. And square root of a perfect square. Okay. We're going to bounce down to variables under the radical sign. And what that means is there are going to be a lot of times where you have a variable underneath. Okay? And what do I do with that? Gosh, it can be so confusing. So it's hard enough to figure out the numbers. Now we're dealing with, what do I do with this here? All right, so what I suggest doing is writing your radical with your index, no matter if it's a 2 or whatever. Okay? So make sure you get your index there. Okay, this is the easy part. What number times itself gives me 25? 5. And I look at this number and look at this number. And what I do is I say, how many times does this 2 go into this 2? How many times does 2 go into 2? 1 time. So I write 1a. And I'm done. Okay? That's all I do. Now, when I come up with other numbers, or other letters, well, let's do example 4. I don't want to get ahead of myself. I'm going to put my index there. Square root of 16 is 4. This divided by this is 1. This divided by this one over here is 1. So I have 1a and 1b, and I'm done. Okay? What if I have the cubed root of 1 25a cubed. Same exact same thing. What number times itself 3 times is 125. 5. 3 divided by 3 is 1. So I put 1a down. Now watch what happens here. Following that procedure, let's put this one next to it. A to the 9th. Now I look at my 125 and I get 5. How many times does 3 go into 9? 3 times. So however many times this number goes into this number is what number you put here. So 3 goes into 3 one time, so I could put a 1 right there, but you don't need to because you look at this and it's obvious there's 1a. I don't need to write the 1 up there because I know it's there. Okay, so it tells you 3 goes into 3 tells you what the exponent is, and without the radical sign. 3 goes into 9 3 times. So the radical sign disappears because 3 goes into 9 3 times. All right, so let's continue on with that because things get a little different. Doesn't necessarily get harder, but you just have to think a little bit more. Square root of x to the 6. So again, put that there. How many times does 2 go into 6? 3 times. That's it. All right. Sometimes when you do these kind of problems, you end up with a radical and a number. Let's say, and I don't know if this section is going to go into this yet, but I'm going to go into it anyway, just so if it does go into it later, you're already familiar. What if I have and it's a square root? What number times itself gives me 25? 5. How many times does 2 go into 5? 2 goes into 5 twice, right? But it doesn't go evenly, does it? So 2 goes into 5 twice, but how many do we have left over then? What's the remainder? There's a remainder of 1, right? 2 goes into 5 twice with 1 left over. So that 1 left over has to stay inside the radical sign, okay? The leftovers stay inside the radical sign. So if I have the cubed root of x to the 14th, if I had, I'll find my eraser here, x to the 14th. Okay, 3 goes into 14, how many times? 3 goes into 14 4 times, with how many left over? 2, right? Whoops, what am I doing? With 2 x's left over. Don't forget to keep your index on there. Okay, so let me look at this again. 3 goes into 14 4 times, so that means 4 of these x's come out, and I have 3 goes into 14 4 times, because 3 times 4 is 12, and I have 2 left over. Well, the 2 left over has to stay under the radical sign. So that's all I did. 3 goes into 14 4 times with 2 left over. So some students will do this. So, and it's got a cube down there. So 3 goes into 14 4 times with 2 left over. And then they're done. It just kind of makes it easier for them. All right, so as we go through this chapter, one of the things that you're going to find is sometimes you're mixing radicals with numbers, or things outside the radical sign. So like a number and then a radical, or a letter and a radical. Okay, and that's okay to do that. It just means that this number is being multiplied by the square root of whatever that is. And so we'll be getting into that, and you'll be doing quite a bit of that. But example 7 says, use a calculator to find out what something like the square root of 12 is. And when you find the square root of 12, there's not a number multiplied by itself that gives you 12. So you know that you're going to get a number 4, 6, 4, and it's going to go on forever. Or if you have, what if you have, like b says 2 square root of 3? That means you're going to take 2 times whatever the square root of 3 is. So 2 times 1.732. You take your calculator out and you find out what the square root of 3 is. It's that. And you're going to multiply it by this 2. And then you're going to get an answer of something like 3.464. If you took the square root of 45, you take your handy-dandy calculator out and punch that in, and you're going to get a number, again, that goes on forever. 3D is 3 square root of 5. It's going to be 3 times whatever your calculator says the square root of 5 is, which will be 2.236, and it goes on forever, but we're just going to stop at 3 digits, and it gives you, okay? But for the most part, you are not going to give me answers like this unless it specifically asks you for a decimal. What we're going to do is we're going to leave them in radical form. So what I'm going to do is I'm going to teach you how to do what is called simplifying radicals. That means when I have something like the square root of 12, rather than write it as a decimal like 3.464, I'm going to have you write it as a radical but simplified. So it's kind of like taking 2 over 4 and writing it as 1/2. You know, you reduce it, you simplify it into its simplest form. The same is true with a radical. To simplify it means we're going to put it in its simplest form. Basically what that means is we are going to make the number under the radical as small as we can possibly make it. Okay? So what that means, when you're given a radical that you can't look at like this one and say, what are 2 numbers multiplied together that give you this number, which there aren't any. I mean, 3 times 3 is 9, 4 times 4 is 16, and there's no number in between 3 and 4 that would multiply together that gives you 12. So there isn't one. So all you can do is simplify it. Okay, so what I do to get you guys started on this is I have you write the square root of 12 as the product of 2 numbers. So what 2 numbers multiplied together give me 12? Well, 3 times 4 does, but so does 6 times 2. And so does 12 times 1. So which one do you pick? Well, I always tell students to pick the 2 numbers where one of them you can take the square root of. Okay, can I take the square root of 12? No. Can I take the square root of 6? No. Can I take the square root of 2? No. Can I take the square root of 3? No. Can I take the square root of 4? Yes. That's the one I want. So what I do is I say, all right, so take the 2 factors, the 2 numbers multiplied together that give you 12, where one of them you can take the square root of, and then you can pull that out. So what is the square root of 4? It's 2. Do I know the square root of 3? No, so I leave it alone. That is the simplified version of that. And you'll be able to do these in your head after a while. So let's look at the square root of 18. Well, there's 6 times 3, there's 9 times 2, and there's 18 times 1. Which one has a number that I can take the square root of? I can take the square root of 9. So I'm going to write the square root of 18 is the square root of 9. Can I take the square root of 2? No, so it has to stay under the radical sign. So I find a number, 2 numbers multiplied together that give me 18, where one of them I can take the square root of. I take the square root of it, pull it out of the radical, and leave the other number in there. And there will always be another number in there. All right, so let's look at square root of 8. Well, I've got 4 times 2. Do I know the radical or the square root of either of those numbers? Yeah, I know the square root of 4 is 2, but the square root of 2 doesn't have one, so it stays in there. This is the simplified version. Remember I said a simplified version makes the number under the radical as small as possible. All right, so I'm going to end this video here, 8.1b, and continue on with 8.1c.